So what is a radian and why do we use them? And for what's on the minds of many high school students, why don't we just use degrees? That's what we're most comfortable with. Well, let's take a look. What is a radian? So by definition, a radian is an angle measure that gives the following ratio: the length of the arc divided by the length of the radius. So when the length of the arc equals the length of the radius, the angle has a measure of 1 radian. We often use the Greek letter theta to represent the angle. Or, when the length of the arc is twice as long as the length of the radius, the angle has a measure of 2 radians. And theta is equal to 2 radians. When the length of the arc is 3 times as long as the length of the radius, then theta is 3 radians. But here's the payoff. When the length of the arc is pi times as long as the radius, the angle has a measure of pi radians. So halfway around the circle is pi radians, or all the way around is 2 pi radians. A unit circle is a circle with radius 1 in the center at the origin. So here the radius is 1. So length of the arc divided by length of the radius just becomes length of the arc. So the radian measure of an angle for a unit circle is equal to the length of the arc that it subtends or cuts off. Why do we use radians? Using radians makes some formulas simple, while the same formula is much more complicated with degrees. Here's an example of a formula in radians and the same formula in degrees. This is a formula where S is the arc length and R is the radius, giving theta. Radians are very important in calculus. So the area under this curve y equals the sine of x from 0 to 180 degrees is approximately 114.6. If you look at the same graph and you graph the independent variable in radians, that area is exactly 2. So that's an introduction into radians, and here are a couple of historical references to the first usages of radians and degrees.